Hello, good morning, good afternoon, and good evening. On behalf of PioPetro and Military Research Hub, I'd like to welcome you all in our Q&A session. My name is Mayar Tor, a senior gas and petrochemicals engineering student, an SPE Egypt Young Professional member, and I'll be your moderator for today. So before we start, please keep the chat box professional and ethical, and don't forget to drop your questions in the Q&A section below. So without further ado, let's welcome Dr. Ahmed Algarhy. Dr. Ahmed Algarhy is a distinguished professional with over 20 years of experience in the energy and petroleum industry, specializing in production enhancement services. Dr. Ahmed's expertise includes acidizing, hydraulic fracturing, geomechanics, geothermal energy, carbon capture, utilization and storage, and hydrogen technologies. Dr. Ahmed has successfully led projects for major companies like Apache, Chevron, BP, Shell, and Total. Currently, Dr. Ahmed, a research manager at Military Research Hub. He has a proven track record in publishing applications in energy, on machine learning. His academic tenure as an assistant professor at Merita College underscores his deep knowledge in production enhancement, petrophysics, and well logging analysis. Dr. Ahmed holds a PhD and master's in petroleum engineering from Texas Tech University. He has published over 30 research papers and received the Distinguished Achievement Award from SBE International in 2021. Thank you so much, Dr. Ahmed, for coming today, and the mic is yours.
Maya, thank you very much for the introduction. As we agreed with everybody, this course planned to be 4 lectures, and lecture number 5 is questions and answers. So in my last lecture, I asked you to write your own questions below the YouTube videos. After we do the lecture, we post the video the same day on YouTube, and I copied your questions from from these videos, and today I will try to answer them one by one. Okay, so Maya, if you want to help me reading questions.
Yes. Is there a natural way of increasing formation permeability with necessarily using any of the simulation enhancing techniques?
Guys, this is a very good comment or a very good question. But remember, all the time, think about the original state of the reservoir, the original permeability of the reservoir. There's 2 important parameters you need to understand very, very well. Number 1 is the porosity. We are talking about sedimentary rock, has organic content, has maybe oil or gas, and this rock should have a porosity, good porosity. Good porosity is something like, let's say, 5%, 10%, 20%. So we expect something, what we call it good porosity, let's say if we are talking about conventional reservoir, like a sandstone formation or limestone formation or dolomite formation, for example, something between 10 to 25%, I would call this very good porosity. Okay, this is the storage ability of my reservoir. Okay, if I'm talking about tight sand, or I'm talking about organic shale gas or shale oil, I'm expecting most likely something less than 10% porosity. 5%, 7%, most likely we are talking about numbers less than 10%. Okay, so the second important parameter, what we call the permeability, the movability of these fluids, which is maybe water, maybe oil, maybe gas, how easy these fluids can move from a place to a different place inside the reservoir. Okay, we call this the permeability. A parameter describes how easy the fluid can flow inside the reservoir. Okay, so before any formation damage, before any fracking, before any acidizing, or before any formation damage because of the drilling of fluids or completion fluids or whatever. Okay, we call this is the original state of the reservoir. This is the original permeability. Let's say it was 5 millidarcy, for example. Okay, so There is no natural way to improve, to enhance permeability without doing something to the reservoir. You cannot say, I will leave the reservoir for 10 days or 100 days, and after that, the permeability will improve. You need to do something to improve the permeability. Something like what? Something like you may do hydraulic fracturing. Remember, even if I'm saying doing hydraulic fracturing to improve permeability, this is a wrong statement. Hydraulic fracturing is not improving the permeability. Hydraulic fracturing bypassing the formation damage. So, what is improving permeability? Acidizing may improve permeability. Acidizing may improve permeability. Okay, so if you have a limestone formation, and this limestone formation, you do matrix acidizing or acid frac, now you are improving, you are trying to improve the permeability of the near wellbore region. Okay, but if you are doing hydraulic fracturing, you are bypassing the damage. You are trying to make like a highway to cross the damage, but you are not fixing the damage. So when you say hydraulic fracturing improve permeability of the reservoir, this is the wrong statement. Acidizing improve the permeability? Yes, possible. Okay, I hope this is clear to everybody, that there is no way to improve permeability without doing anything, just you leave it for nature and the permeability will improve in a very short period of time, in a month or a year without doing anything. This will not happen. Okay, maybe over millions of years, maybe a chemical reaction happen inside the reservoir, so the permeability will change over millions of years, but this is not your question. You are asking about something in a short period of time. So in a short period of time, if you want to improve permeability, number one, you need to study the chemical composition of your reservoir. What is the minerals in this formation? Is it limestone? Is it dolomite? Is it sandstone? Is it shale? What type of shale? And based on that, you decide what should be the right treatment to do. What is the right chemical treatment? What is the right acid to do to improve permeability? One last time, hydraulic fracturing is not improving permeability. Hydraulic fracturing bypassing the formation damage. If you are talking about acid frac, you are doing frac using acid like HCl in a limestone reservoir or dolomite reservoir. Now you are creating a fracture using acid, and at the same time you are doing something called etching for the two faces of the fracture, and also you are improving permeability for the near wellbore region near the fracture. At the same time, you are dissolving the formation damage if that acid you are using chemically can dissolve the formation damage and the products of that chemical reaction is soluble in water. Okay, so I hope this is clear to everybody. Let's go to the next question.
Can you explain the treatment fluid part? Please, I didn't get it clearly.
Okay, so simply when we talk about hydraulic fracturing, if I want to ask you, what is hydraulic fracturing? Hydraulic fracturing is using a frac fluid or using a fluid. We call it engineered fluid. Engineered fluid because it is designed fluid. I will not go get any water and inject it. I will go get a special water meeting a specific specifications. Okay, I will add some additives. So I will design the frac fluid, okay, to meet physical and chemical properties, okay, and I will inject it in my well, and when it goes to the through the perforation, I will pump it and try to build high pressure enough to break down the reservoir. Okay, so that fluid I'm using, I may use slick water, just fresh water and friction reducer. This is if I'm trying to frack a brittle shale. So brittle shale, the best choice as a frac fluid is to use something we call slick water. And the slick water is just water and friction reducer. Okay, if there's any minor additives, but this is the two main things we are using in slick water. In conventional reservoirs, such as conventional sandstone formation, if you are using slick water, the slick water will leak immediately. The permeability a little bit high of the conventional sandstone, so you cannot build a net pressure inside the fracture. You cannot keep the fracture growing to take the dimensions you want. Okay, so to do this, you need to improve the viscosity of the fluid. You need to make that fluid more viscous. Okay, a viscous fluid, we are using what we call cross-linked gel. We are preparing a linear gel, something like milk, in the shape of the milk. Then we add a chemical to it, make it looks like jello. And I'm using that jello to transport the propellant from the surface and inject it inside the fracture and distribute this propellant in a good distribution inside the fracture. Okay, so that frac fluid is a complex recipe. The same like you are in the kitchen trying to, you watch a cook in the TV trying to make a special food or a new food, something you don't know, and she asked you to bring a list of ingredients, and now you are in the kitchen trying to make that food. Okay, so we call it a recipe. Okay, the recipe, this is the list of instructions you need to do to create that frac fluid. So you may add, for sure you will add water, and for sure you will add propellant. For sure you will add some surfactant. You will add TCL. You will add gelling agent. You will add scale inhibitor. You will add pH adjusting agent. You will add breaker. So there is a long list of additives we add, and each additive do something. Okay, for sure. The first time you will see all this list of additives, you may get confused. This is too much. But trust me, if this is your job, if your job is a frac engineer, within 1 month, you will remember everything about fraction. Again, I always tell my students, to be a good frac engineer, maybe you need something like 6 months. If you are a mechanical engineer, if you are a chemical engineer, if you are an industrial engineer, if you are a civil engineer, and you go for a training to be a good frac engineer, maybe you need something like 6 months to be good frac engineer to start your career. I will not say you will be an expert because you still lack experience, but you can do the major required job. Okay, so I hope this is clear. Let's jump to the next one. So
why do we need to keep the injection rate constant all through?
Okay. So this is a very good question. But please, to ask a question like this, I want you first to watch the 4 lectures. Because sometimes I answer the question during the lecture, and if you did not watch the lecture, you will not understand why. Okay, and again, we were not planning to make this session. It was just planned to be a 4 lectures, and that's it. So when you do hydraulic fracturing, after you do the job, again, you are designing a frac job. And my design will be different if I'm comparing my design with my design, with your design, and we will make 3 or 5 different designs. All of them Possible all of them to be right, no problem. All of them will do the required job. It is like you are designing a house. It is not one answer. It is not one solution. Okay, you need to make a design to create a hydraulic fracture in a good shape, in a good dimension, and you place the proppant in a good distribution inside that fracture. And for sure, you respect and learn from the best practices of the experts working in your company and other companies. Okay, so after you finish the frac job, you need to evaluate the job you did. How I will evaluate the design you did if it is good or not. After we take your design, go and implement it in the field, we need to have a way to evaluate the design you did. Okay, so I will do some well testing right after stop injection to understand the leak off, to get the closure pressure, and after that also I can do some well testing to understand the permeability and understand the reservoir pressure. Okay, so to have models to evaluate post-frac, what we, to evaluate the frac job, we have something like the J function technique. In my in my third lecture, I'm not sure if it is a second, third, but maybe the third lecture, I talked about the J function. It is a mathematical model to evaluate the leak off. Also, with the leak off, I can get the closure pressure. Okay, so the leak off, behavior, and the closure pressure. That mathematical model, for example, has assumption that the injection rate was constant. It means if you cannot keep the injection rate constant, you cannot use the J function technique to evaluate your frac. You get what I mean? So the techniques we are using to evaluate the frac job after doing the treatment, after injecting the treatment, one of the assumptions that the injection rate was constant. So you need to keep it constant so you can use that mathematical technique to get the closure pressure and to get the to understand the leak off. Okay, and I believe in the third lecture I explained that. But thank you anyway for the question, because this is very, very good question. Let's go for the next one. Okay, so this is a comment got from a student saying that he or she cannot understand English, and this is why he cannot benefit from the lectures. Here is a point. Listen carefully. If you decide to work in the oil and gas business, and you will get a job in ADNOC in Emirates, or you get a job with Saudi Aramco in Saudi, or you get a job with Apache in Egypt, or you get a job with Total somewhere, okay? You will find most of the countries that has oil and gas business, they are using English as an official language. You have a colleague from India and you are from Egypt. You are from Algeria and your colleague sitting beside you from China. You will not talk to him in Chinese, or you will not use Indian language, or you will not use your Arabic language. Okay? You need to have something in common to use to communicate, something to use to write an email. Okay? So over a long time, we use English to communicate in the oil and gas business. Back when I was working in Egypt, during the, if you are working for Apache, for example, you have some colleagues coming from the United States. They don't know how to speak Arabic. They don't understand Arabic. So to communicate with them, you need to speak to them in English. You need to write them in English. Okay? If you work here in the United States, like what I'm doing, I have a colleague from Nepal. I have colleague from Bangladesh. I have a colleague from Ethiopia. I have a colleague from China. How we will communicate with each other? So we use English to communicate. So please remember this. If your English is not good, it means your job is to work hard to make it good as possible. Find a way to improve and enhance your English. Get classes, watch American movies, get a training course, whatever you will do, but in a very short period of time, let's say within 1 year, you need to fix this problem. Okay? Also, my advice, watch the video many times, and you can use the translation, the on-time translation by the YouTube, and it can translate to the Arabic language. But please try within 10 months or a year to improve your English. Okay? So now let's go to the next question.
Okay. The pH of frac fluid is usually less than 7. True or false?
Okay, so this is a very good question, but let me ask you first. Please write me in the chat any example for a fluid you are using in the oil and gas business. Let's say frac fluid, drilling fluid, completion fluid, killing fluid. Okay? List all examples you may think about. All fluids we are using to drill a well or to, let's say, the cement we are using, the hydraulic fracturing we are doing, all of them, the pH must be more than 7, except you are doing acidizing. Remember this, because I get many questions about this, and it seems like you are confused about it. Okay? Any fluid you are using in the oil and gas business to drill, so the drilling fluid you are using, the pH more than 7, the cement, the pH more than 7, the completion fluid, the killing fluid, the pH more than 7, the frac fluid, the pH more than 7, except when you do acidizing, because by definition, if you are using HCl or organic acid or whatever acid, the pH will be less than 7. More than 7, this is alkaline. Less than 7, this is acid. And 7, this is neutral like water. Okay? So remember, all the fluids we are using greater than 7, except when you do acidizing or acid frac. That's it. Acidizing or acid frac, the pH will be less than 7. Okay? The second part of the question, why? Because I am injecting, let's say I'm using a production tube or frac tube or whatever, we have casing, I have a tube, I have all these things, most of them made out of steel alloys. And corrosion is a big problem. So to minimize the chances for corrosion, it is better to use something not acidic. If you're using something alkaline, you are minimizing the chances for corrosion. Okay? Because this question, many of you get it wrong, and many of you has like the opposite belief. Okay, so I hope now it is you have the right information now. Okay, let's jump to the next one.
During hydraulic fracturing, do we pump the fluid through the production tubing or through coil tubing?
Okay. So as a completion engineer, when you decide to implement a frac job, you design for it. Let's say I have a sandstone reservoir in the Western Desert in Egypt or somewhere in Algeria, in Hassi Masoud in Algeria, for example. Okay. And let's say I have a sandstone formation and I have a vertical well or slanted well. So you may use a production tube or just a tube, 3.5 inch, something like that. You can use it to frac the formation. So you have the tube, you have a packer, and you set the packer right at the top of the perforation, and you can test that the packer is okay and everything is the backside pressure is constant, stay constant, and you can do your job, do the frac job. Okay. What if you have a horizontal well and it is open hole completion, there is no casing as a production section, and it is carbonate formation. Also in the Western Desert in Egypt, in Abu Gharadi area, we have something like that. In Emirates, in the Gulf area, in the Middle East, we have many carbonate formations. Okay, and you decided, oh, it seems like if I will use a coil tube and do acid frac and I will inject acid in a pressure higher than the parting pressure of the formation and I will do multi-stage acid frac, so maybe it is better to use a coil tube. So using a coil tube or using a tube, this is your decision and this is your design. How you do it based on your experience. If you don't have enough experience, you follow what is the experts in your company used to do. Or you learn about what his neighbor companies doing. Okay, but the answer for this question, we do both based on the case. I will decide a coil tube is better or using a production tube is better. Okay, but you can do both. Okay, let's go to the next question.
Please clarify after submitting the assignment, what do we have to do? Any attachment or mark it as work done till now, no clear guidance. There
What you
is
need
clear guidance. Come on.
what you need to do, number one, you do your best to attend the Zoom meeting. So
Sorry?
when you do your best to attend on Zoom. Let's say you have something more important, you have emergency, the time was not good for you. So wait and watch the video on YouTube at least one time. When you watch the video, try to take notes. Don't say I'm just watching. You're having a summer training to learn. So you cannot learn without writing notes. By the way, when I used to go to the field, when I was working with Apache or even here in the United States, all the time in my coverall, I have in my pocket, I have a note and I have a pen. And whenever I learn something new, I write it down. Because if I will not write it down, for sure, the second day I will forget it. This is nature. So try to write notes when you watch my video, other professors or expert videos, try to write notes. This will help you to learn faster. Okay? After you write your notes and you watch the video and you get the feeling that you already understand the topic and you understand the lecture, go and do the quiz. If you do the quiz and you get confused about one or two questions, you may do your own search on Google. All of them are easy questions, but maybe just because you are new to the topic. But if you check Google, or you will find explanation for any question. Okay, and After that, just you wait, you submit your quiz on time, the answer on time, and you wait after we finish the course, because within 10 days, we will make a final exam for that course. Then you will receive your certificate. And we use many of the questions we use in your quiz. So this is why we don't want to share the answers with you early, because you may see these questions again in your final exam. Okay, but I just try to attend Zoom, watch video, take notes, do the quiz, and wait for the final exam of that subject. Okay. Next question.
Please, why is the pH of rock fluids greater than 7? I don't understand.
I already explained this, mainly to avoid any chances for corrosion. We use a lot of corrosion inhibitors, and just to try to extend the life of the tubing I'm using. We are trying to save this tubing to live for a longer time. Okay, so keeping the pH higher than 7, especially because I'm using a lot of water. So by doing this, I will minimize the chances of corrosion in the system. So this is why we are trying to keep it above 7. Next question.
Why are there a for converting to static?
Okay, so your voice, the connection was not good on your side, so I will read the question from my side. Why are there a lot of equations for converting dynamic to static Young's models? I will tell you why. Let's say I'm working, I live in Ohio, and I live close to a shale play called Marcellus Shale. Marcellus Shale, like 100 miles away from my home, like in Pennsylvania, for example, and West Virginia. Okay, and I developed a correlation to convert dynamic Young's modulus to static Young's modulus in Marcellus Shale area in Pennsylvania and West Virginia and Ohio and north of New York. Do you think you can copy this equation I developed here for a specific location and apply it in the Gulf area in the Middle East? Write me in the chat, yes or no. Do you think you can use the correlation to convert dynamic to static Young's modulus developed for Marcellus Shale or Gulf of Mexico, for example, here in North America, and use it in the Western Desert in Egypt, or use it in Algeria or Libya, for example, or use it in Iran, or use it in India? Do you think this is something right to do? No. The Earth is not the same. The formation is not the same. There is no identical reservoir on Earth. You will not find two reservoirs. There is some similarity, but they will not be identical. Okay? So you need to develop your own local correlation for a specific reservoir. You are working in Saudi, in a specific place in Saudi, you need to develop a correlation to convert dynamic to static Young's modulus developed for that place. And you cannot take this equation and apply it in Gulf of Mexico or apply it in Latin America, for example. You cannot do that. This would be a big mistake. Okay, this is why if you ask someone list correlations to convert dynamic to static Young's models, he can list 1,000 correlation or 10,000 correlation. Why? Anyone working anywhere can develop a local correlation. So, but you cannot use most of them if they are not developed for the same place you are interested in. You cannot use them. So the conclusion, You need to develop your own local correlation to convert dynamic to statistical models in the reservoir you are working on, or in the field you are working on. Okay? Let's go for the next question.
Why is the fracture direction perpendicular to the minimum stress direction?
Okay, so I need some imagination because it is better to show you a picture, but because I did not prepare a picture, so please I need good imagination with me. Okay. We agreed that let me use okay. So I have a picture at the end, and I will, when we go to the end, I will explain it one more time. So we have three principal stresses. We are using three principal stresses. I'm using the overburden, which is vertical, and I'm using two horizontal stresses. The higher in magnitude, I call it the maximum horizontal stress, and the lower in magnitude, I call it the minimum horizontal stress. Okay, so let's imagine that the overburden has the highest magnitude. So the magnitude of the overburden is the highest. And the second is the maximum horizontal stress. And the third in magnitude is the minimum horizontal stress. Okay? If you are planning to break one of them, which one is easier to break? Write me in the chat. In this scenario, which one is easier to break? The minimum horizontal stress or the maximum horizontal stress or the overburden? And remember, the overburden is the highest in magnitude. Which one is easier for you to break? So I get two answers. One wrote, I will break the maximum, and one wrote, I will break the minimum. Guys, breaking the minimum is easy because his value is small. If you have someone strong and someone weak, and I'm asking you to fight with both of them, which one you will choose? You will choose the weaker one because you can beat the weaker one easily, right? So you will break the minimum horizontal stress. So when you open a fracture, against the minimum horizontal stress, you will see the fracture growing perpendicular to that direction. When you open a fracture against the minimum horizontal stress, you will see the fracture growing perpendicular to the minimum horizontal stress direction in that case. Some people say, oh, it grow with the maximum horizontal stress because also the maximum is perpendicular to the minimum. But remember, the right thing to say, the right answer, the perfect answer, the fracture will grow perpendicular to the least stress. If the least stress is the minimum horizontal stress, so it will be perpendicular to that. If the least stress will be the overburden, so the fracture will be horizontal and it will be perpendicular to the overburden in that case. Okay? So why the direction is perpendicular to the minimum? Because simply you are opening a fracture against the minimum. You are beating the minimum. So your fracture open and you see it growing with the direction perpendicular to them. Okay, I hope this was clear. My apologies that I did not show you a picture. It is better to use a picture for that. Next question.
How can we check the results of acidizing and hydraulic fracturing in the real time?
Okay. This is an interesting question. But trust me, there is no way to evaluate the permeability change or let's say the stimulation improvement, because the acidizing change permeability, but the fracturing is creating a new high conductive pathway, which is a fracture itself. So the technique of improving production is different from comparing acidizing with hydraulic fracturing. The techniques are different, but both of them, they are improving productivity. But what we can say, there is no way to see this production enhancement on time. We evaluate what happened after the fracture. After you finish the job, after you finish the acidizing job, you can evaluate. After you finish the hydraulic frac job, you can evaluate. After you finish the acid frac job, you can evaluate. But during the job itself, there is no way to see the change or the improvement, okay? Only what you can do is to do some simulations. But you remember, simulations are just simulations. So a simulation software, this is a way to a design tool, okay? But there's no guarantee that what you see in the design or in your software maybe will be like a 70% agreement with the final result or 60% agreement with the final result. So there is no guarantee that what you see in the simulation is exactly what you will see in the implementation. Most likely, if you have a software can get you 75% of what would happen, I would call this is a good software. Okay, so to conclude or to summarize, there is no way to see the production enhancement during the job itself. The maximum what we can do is just simulations, and simulation, this is just mathematical models and a lot of assumptions, so there is no guarantee that this is exactly what is going on. Okay, all what we do after we finish the job, after we stop pumping, we do what we call post-frac evaluation or post-acid evaluation or post-acid frac evaluation. Okay, next question.
When we perform BU test after a successful hydraulic fracture, is it correct to expect to interpret a higher permeability than a BU test performed before HF?
Okay, so BU, he mean build-up test. Okay, and HF, this is the hydraulic fracture. Okay, so he is using like a short names. Okay, so for sure, if you will do a build-up test before doing a hydraulic frac job to evaluate the permeability and evaluate the skin you have, to evaluate the formation damage you have and evaluate the permeability. For sure, if you will do a good design for a frac job, and after you do the frac job and you start evaluating, let's say, the permeability, or to evaluate the production, for sure you will get a higher production if you do it right. Okay? But remember one more time, look to this picture. In the middle, this is the wellbore, and the red, this is the formation damage. Okay, we call it the damaged zone. And the green, we call this is the invaded zone. It is also damaged, but less damage. Okay, look to the hydraulic fracture. The hydraulic fracture, not fixing the damage, not removing the damage. It is bypassing the damage. It is creating a new conductive surface connecting the reservoir with the wellbore. If you remember in my first one or two questions, I told you hydraulic fracturing, not removing damage, not fixing damage. It is bypassing damage. Bypassing damage like jump the damage, skip the damage. The damage as it is in the formation, but he creates like a highway, and use the highway to collect the hydrocarbon and water and all the fluids from the reservoir to the wellbore. Okay, what is fixing the damage or what is removing the damage? Most likely acidize. But you need to check the chemistry first. If the chemical you are using or the acid you are using can dissolve the damage or not. This is the question you need to answer first to select the right chemical or the right acid system so it can dissolve the damage, and the result of that chemical reaction will be soluble in water, so you can produce the solution back to the wellbore during the early production period after you finish the job. Okay, so evaluating the permeability after the frac, I'm not changing the permeability of the formation. I'm not changing the formation damage. I'm not removing the formation damage. But after the build-up test, if you do build-up test before the frac job, you will find productivity less than what we get after fracking. But the permeability will stay as it is. The permeability of the reservoir will not change. Okay. Also, to make it easy to remember, hydraulic fracturing improves productivity for few reasons. Number one, hydraulic fracturing increase the contact area between the fracture between the reservoir and the wellbore by fraction. So increasing contact area between the reservoir and wellbore. This is number one. Number two is bypassing the formation damage, bypassing the crowd surrounding the wellbore that stop the production or stop the fluids from flowing, okay, by creating a very conductive new surface using the proppant that keeps the fracture open. Okay, so this is why fracturing improves productivity, but you will not find in the list anything about removing damage or dissolving damage. Fracturing will not do that, except you are talking about acid frac. And the acid you are using can dissolve that precipitate in the formation that's making the damage. Next question.
I checked the quiz in Google Classroom and I saw some questions about certain additives, and these additives haven't been mentioned yet. So, do we wait till the fourth lecture and then do the quiz?
Please, when you see an additive or something you did not get in the lecture, try to do your own quick search about it. If you see a question about breaker and I didn't tell you what is a breaker do, all what you need to do, go to Google and write what is the function of breaker in hydraulic fracturing. You will find many resources give you a very simple explanation. So I totally understand that, yes, maybe some questions you did not get clear explanation for it, but trust me, they are simple ones. Do your own quick search, try to get the answer after the quick search, and solve the quiz, solve the question and submit it. Next question.
I would like to know the difference between pad volume and clean volume.
Okay, so the pad volume is the volume we inject at the beginning of the fracturing treatment. We start with it. It is a frac fluid without any proppant in it. Frac fluid at the beginning of the treatment without any proppant in it. And its function is to break down the formation, create or initiate the fracture in a good shape so the fracture can accept proppant coming after the pad. If you start without a pad, if you do the fracking without any pad volume, you will get early screen out immediately. You cannot grow your fraction. Okay, so the pad volume is a frac fluid without proppant. We inject it at the beginning of the frac job. Okay, the clean volume is the total volume of all fluids are used without proppant in it, including the pad. So clean volume, the opposite of clean volume is a dirty volume. Dirty volume, this is the volume of frac fluids, including proppant in it, has a proppant in it. When you see it, you will find it gray, has a gray color because of the proppant in it. The clean volume is the total volume of fluids injected and has no proppant in it. The pad volume is the only portion we inject at the beginning without a proppant. Okay. Next question. Seems like we are running out of time, so.
Dr. Ahmed, I have a question. What is
Sure.
the role of chemical engineer in the hydraulic fracturing?
Okay. All the frac fluids. So let's say, what is the role of chemical engineering and production enhancement in general? Okay. When we talk about frac fluids and you see a long list of additives, of chemical additives, okay, and we need to invent new additives to do the same function. For example, if you want to use a chemical to dissolve scale from ASP pump, for example, or a scale from a tube we are producing, or you want to find a chemical, let's say, to kill or to prevent sulfur-reducing bacteria, for example, or in acidizing or in acid frac. All these things are chemicals. And the best one understand this chemical
Thank
engineer.
you.
Okay, so a chemical engineer has a very important role in production enhancement in general, especially
Yes.
in evaluating formation damage and fixing formation damage in hydraulic fracturing, in acidizing, in acid frac. All these things has an important role for a chemical engineer.
Okay, thank you.
Okay.
The next question, I heard that in your videos, their certificate for hydraulic fracturing course, one other in the internship as well. I have challenge of attending the Zoom meetings because of job schedule, but I have watched all the videos and completed the assignment. Will I get these certificates you mentioned at the end of the internship?
Okay. So all the time we say this, do your best to attend Zoom, except you have a good reason. If you have a job and your employer don't allow you to watch these videos, or in a place that you don't have a good connection, go and watch the YouTube videos and try to submit the answers for quizzes on time. Okay? When we announce for the time for the final exam for a specific training, let's say after 10 days from today, for example, I will ask you to do a final exam in the 5 lectures I explained. And I will give you a certificate on introduction to hydraulic fracturing class. This is part of the training. If you attend, let's say 70% of the training, we will give you a certificate for the training, for the all training together. Okay, so at the end of this training, at the end of, let's say in August, you may receive 10 or more different certificates. Okay, so please do your best to attend Zoom, except you have a good reason. If you have a good reason, just text me in LinkedIn, send an email just to make a case that, hey, I will submit quizzes, I will submit the final exam, I will watch videos, but please, I have a work or I have an emergency, and this is why I did not attend at that day or that week. Okay, let's go to the next one.
It's someone is saying thank you very much for the lecture. I'm not receiving the assignments.
Okay, so whenever you see someone writing this, it means he or she don't know that we are using Google Classrooms. So we have 5 Google Classrooms, and you need to join only one. So some of you in classroom number 1, some of you in classroom number 2 or 3 or 4 or 5. So this guy, I believe he may watch the YouTube, he may attend the Zoom, but he don't know that after he fills the application, the registration application, he need to receive a code or a link to join one of the 5 classrooms we have. If he or she joins the classroom, the Google Classroom, for sure he will find or she will find the quizzes there. So please, if you don't have one of these 5 classrooms, you need to join or you need to ask how to join one of these classrooms. Next question.
Dr. Ahmed, someone is asking in the Q&A uh, part why the minimum skin factor we can get is about -4, not less.
Okay, we call this is practical. So let's say you work in the business for 20 years or 40 years or 30 years, and you say, okay, it seems like there is a difference between having an equation or doing something in a book, something theoretical, okay? But after you see hundreds or thousands of cases, you start getting your own evaluation for things, okay? So the equation we use, let's say, to have, let's say, the permeability, let's say after, sorry, the skin factor after fracking or after acidizing. Okay, we notice that we can see a positive 100 or positive 50 or positive 150. It happens, but we never found a case that we get less than -4. This is like a fact. Okay, but because the correlation of the equation we are using is not perfect, so it may give you -5 or -6 or -7. But when you see -7 on paper and you link this with your own experience, you will say, okay, -7, this is only on paper. This will not happen. Okay, so just you can say nothing, you will not get a skin factor less than -4 because it seems like this is nature, or this is the physics of Earth. Over 100 years, let's say we are developing oil and gas, let's say 200 years now, 150 years, like a long time. Anyway, it is more than 100 years. And we have never, we never seen a skin factor less or, after stimulation. So we started hydraulic fracturing in late 40s, let's say, starting from 1948 or something like that. Okay. And from that day, we never seen any skin factor after frac job or after acid frac job or after acidizing job went less than -4 in the real life. Okay, so you can just say it is physics, the physics of Earth. This is like a nature. Okay, let's go to the next question.
Dr. Ahmed, there are so many questions saying that they submitted the quizzes, but they are still shown as missing. So is there a problem or they are already assigned?
Whenever you are sure that you submitted, sometimes you get this mistake. We go and check and we find the quiz there. No problem. Don't worry. If you submit it, it means that we receive it. Even if it shows that they're missing or not submitted or whatever, don't worry about that. Next question.
Is this course only attributed to onshore oil and gas or offshore oil and gas or both?
Okay, so when we talk about something like fracturing or acidizing, or there is some topics. There is a big similarity between what we do onshore, offshore. For sure, when we talk about offshore, for example, we may care about things like frac and pack, and doing hydraulic fracturing for sand control, for example, not to improve productivity in many cases, like in Gulf of Mexico, for example. But there is a big similarity between what we do onshore and what we do offshore. For sure, there's some differences, but it is too early for you to think about these things now. If you talk about drilling, you will find very big similarity. If you talk about production, if you talk about evaluating reservoirs, there's a very big similarity. Let's say the drilling rig I'm using in offshore, for example, in deep water, for example, you may find the tower of the drilling rig, for example, is like 4 pipes. Okay, on land, you may find it 3 pipes. So the tower on the sea, if you are drilling in the deep water, for example, you may find the tower of the drilling rig is higher, but the same components, the same technique, the same ideas. Okay. In this training, we ask volunteers to teach, but we need to have qualified volunteers. So we go and talk to good experts from universities, good experts working for famous companies, and their English is clear. You will not have problems understanding them. Okay. You may get an expert in onshore or offshore. This is based on who's volunteering. Okay, but again, if you're still a student, don't think about these minor differences. Just focus and try to learn from all lectures as possible. Next one.
When having high value leak off isn't desirable, but isn't mean that you have a net of fractures inside the formation rather than, let us say, long fracture, and why the second is one desired.
Okay, so this is a hard and tough question because there is a big debate about what is exactly happening inside the formation. Okay, for a long time before developing or massively developing shale, when we were just fracking sandstone formation or limestone or dolomite, we always think about bi-wing fracture, a fracture that has 2 wings going or growing in a direction perpendicular to the minimum stress. Okay, when we started developing shale and we get new concepts, new ideas about fraction. So let's say one of these ideas, when you fracture brittle shale, for example, using slick water, you create something like a complex fracture system or fracture network. Let's say you have many cracks going to random directions. It is not one fracture, 2 wings anymore. Okay, we call it complex fracture system or complex fracture or SRV, stimulated reservoir volume. Okay, and this idea has a lot of supporters, but later we start getting debate again. No. Even in shale, we have bi-wing fractures. So there is two groups. One group still believes that even in shale, we have two wings fracture. And another group believe, no, we get fractures, thousands of fractures going to random directions, and it is better to use a concept like stimulated reservoir volume or a concept like complex fracture network. So I cannot guarantee which group is right and which group is wrong, because each group has very famous names and very famous scientists supporting them. But all what we can do is we need to learn about both ideas. Okay, so in shale, to summarize, in shale, if you have brittle formation, it is better to use slick water. And we expect to get random fractures going everywhere, all directions. Okay, if you have less brittle or you have ductile shale, I am expecting to have bi-wing fracture. And it is recommended to use slick water or to use a hybrid system, like bi-wing fractures, you should use cross-linked gel. Okay, so high brittleness formation, use slick water. Less brittleness or ductile formation, use cross-linked gel or hybrid system. Okay, so there's a lot of things we still don't understand about shale. And I'm telling you this to motivate you to work harder as a researcher. You may find something, and you may get better conclusions, and all of us we can learn from your research later. Okay, I'm not sure if you like this answer or not, but trust me, there is no guarantee about what is exactly going on when we talk about shale. Okay, one more last thing. That all the time when we talk about conventional fracturing, when you talk about organic, even when you talk about organic shale, if you want to create a fracture, I want to make the fracture dimension under control during the fracturing treatment. This is why I want controlled leak off. I don't want a very high leak off. I don't want very less leak off, because both of them are bad. Zero leak off is bad. Very high leak off is bad. We need controlled leak off so I can keep the net pressure to the value I want, or to the range of values I want, so I can grow the fracture the dimensions I want. Okay, let's go to the next one.
I understand the idea behind using slick water for fracking non-conventional formation. That is pumping fresh water plus friction reducer at very high rates. However, I was wondering why fracking for conventional wells has to be the cross linker gel. Is there anything else that works?
Okay, the main difference between conventional reservoirs and unconventional reservoirs is the range of permeability. If you have very little permeability, something by nano, 100 nanodarcy or 500 nanodarcy, nano is like a 10 to power of -9, something very, very, very small. Okay? If you have something by nanodarcy, like 100 nanodarcy or 500 nanodarcy, for example, you cannot use cross-linked gel in that case. If you use cross-linked gel, it will most likely it will be hard to inject. It will be hard to inject. Why? Because the leak off will be very, very small, and you keep ballooning the fracture, and the surface injection rate will keep growing very high, rapidly, very quickly, and it is hard to do the operation. Okay, and because of the permeability very, very low, so injecting a slick water, just water, the viscosity very low, this will be easier to inject. It will be easier to inject. Sometimes we inject a hybrid system. Let's say part of the treatment is slick water and part of the treatment is cross-linked gel. But again, this is you do this design after fully understanding or understanding as much as possible the formation properties, the permeability, and the natural factors and everything about the formation before you frac it. Okay, so there is good candidate. Based on the reservoir, based on the understanding the reservoir, is it a sandstone formation? The permeability is high, for example, or if it is tight sand and permeability very low. So based on understanding the properties of your reservoir, you decide what is the right or what is a good candidate for the frac fluid to use. Okay. So if the permeability very low, most likely high viscous fluid will not work. If the permeability very high or in a good range, so cross-linked gel will be your right choice. Okay. Remember, the frac fluid, the main function of it is to break down the formation and carry the proppant and place it in a good distribution inside the fracture system you are creating. Keep this in mind. Next question.
What are the key differences between conventional reservoir completion and shale reservoir completion techniques?
Okay. So the main difference between conventional and unconventional is the permeability. So if you have very low permeability, I will call this unconventional reservoir. If you have tight sand, I will call this unconventional. If you have coal bed methane, very tight formation, I will call this unconventional. If you have shale gas, shale oil, and the permeability very low, I will call this unconventional. Okay? If you have sandstone formation and the permeability in a good range, let's say 5 millidarcy, 1 millidarcy, 10 millidarcy, I will call this is conventional. Why? The conventional reservoir, you can produce it using fracking or not fracking. If you are not fracking, you still can produce some of it. Okay? If you drill vertical, you can produce some of the hydrocarbon. Okay? But for unconventional, you cannot produce it economically without doing horizontal drilling and without doing multi-stage fracturing. You must, based on today's technology, you must do these two, horizontal wells and hydraulic fracturing. This is for the unconventional. If you use slick water, if the formation is brittle and you can use slick water, this will make it even better and more economic. So conventional or unconventional, mainly the main difference is the permeability range. Okay. Next question.
How does the complexity of fractured networks impact the overall productivity and efficiency of the shale gas and oil wells?
I think we already answered this in shale gas and shale oil, assuming the formation is brittle, like Burnett shale, for example. Okay. When you fracture, I'm assuming I'm getting more fractures in random directions. So this fracture network I'm creating by fracturing will add more ways or more paths for the hydrocarbon or for the fluids inside the formation to go through it and get produced, go to the wellbore and get produced. Okay, so I'm creating this complex fracture network by fracturing. This will make the fluids, will give the fluids easier ways to reach the wellbore and get produced. And this is how we produce the organic shale and organic gas and the organic shale, the shale gas and shale oil by doing hydraulic horizontal drilling and doing multi-stage fracturing and using slick water if the formation is brittle. Next question. Okay, let me read this question, Mayar. I like this question very much. So guys, please give me all your attention. Okay, so one of you wrote me, and I believe he's not a student. He seems like he's an expert, and he understands exactly what is the difference between a tensor and a vector. So it seems like he has some good work experience. And he wrote a very good comment. He wrote me, stress is a tensor and not a vector, as mentioned in the lecture. Okay, so before answering this question or commenting on his comment, okay, we need to ask first, what is a tensor? What is the definition of a tensor? And what is the definition of a scalar? And what is the definition of a vector? Okay, so I get you this definition from University of Cambridge. What is a tensor? Okay, so Mayar, can you read the definition for me? Starting from, in fact, tensors are. Okay, let me read it. In fact, tensors are merely a generalization of scalars and vectors. A scalar is a zero-rank tensor. So scalar, even a scalar is one of the tensors. So it is a special type of tensor. So a scalar is a zero-rank tensor, okay? And a vector is a first-rank tensor. So I have a zero-rank tensor, a first-rank tensor, a second-rank tensor, a third-rank tensor, and so on, okay? The rank of a tensor is defined by the number of directions. The number of directions. Remember this definition carefully, because I will ask you questions very soon. Okay, the number of directions. Okay, hence the dimensionality of the array required to describe it. So I will ask myself, is the thing I'm talking about has a direction or not? And how many directions? And based on that, I will decide what kind of tensor I will describe it. What kind of tensor will describe it. Okay, look. A scalar, write me in the chat, a scalar has a direction or not? The scalar value has a direction, yes or no? Write in the chat, scalar has direction or not? Scalar is just a magnitude, just a value, has no direction. Okay, so scalar is zero-dimension tensor, has no dimension, has no direction, sorry, zero-direction tensor. What about vector? The vector has direction or not? The vector has direction or not? Write in the chat. Vector has direction, yes or no? Yes. Vector has a direction. How many directions for a vector? A vector has just one direction. Okay, so this is one direction tensor. So so scalar is a tensor. Vector is a tensor. Matrix is a tensor. Okay, so the vector has just one direction, so I would call it one direction tensor. Okay, for the matrix, for this one, I have one, this is one direction, and this is a second direction. So a matrix is two-direction tensor. Okay, look to the other side. Zero direction tensor, this is scalar. One direction tensor, this is a vector. Two direction tensor, this is a matrix. Three direction tensor, this is 3D. We have X, Y, and Z, three directions. And so on. You can have 4D and 5D and so on. Okay. If I'm talking about stress, the principal stresses, how many directions for, if we are talking about principal stresses, how many directions? Principal stresses, how many directions? If I'm talking about principal stresses, there is an overburden has a direction, minimum horizontal stress has a direction, maximum horizontal stress has a direction. So I have three directions for these three stresses. So at any point in Earth, I will ask you what is the direction of overburden, what is the direction of minimum horizontal stress, what is the direction of maximum horizontal stress, and I will ask you about the values, the magnitudes of each one, right? So stress in this case, it is a tensor. Yes, it is a tensor. Okay. But if I'm talking about overburden stress only, and I'm asking you how many directions for overburden stress? How many directions for overburden stress? Just one. If I'm asking you what is the direction of your body weight, you will tell me because of gravity, my body weight pointing to the center of Earth. Because it is one direction. So now you can call it 1D tensor, or you can call it vector. This is why I told you the minimum horizontal stress is a vector, the maximum horizontal stress is a vector, the overburden stress is a vector, because each one of the three is one dimension tensor. If you talk about all of them together, and I have three directions, still a tensor. But when we were talking last lecture or last two lectures, I was not meaning the principal stresses in general. I was talking about each one separate. The overburden is a vector, the minimum horizontal because it has just one direction. Each one has just one direction. But all of them together, if you're talking about stress in general, now you have three different directions. So you have a tensor. You're represented by a tensor, not a vector, because a vector has just one direction. I hope now you understand the difference between scalar, vector, and tensor. So let me check if Mayar is still here or okay, yeah. So this is my last slide. Two things. This is to remind you about the principal stresses. Here is sigma 1, this is the overburden. Here is sigma H max, and here is sigma H min. The sigma H min, in this case, sigma 3, this is the minimum horizontal stress, and sigma H max, this is the maximum horizontal stress, and sigma 1 in this case is the overburden. Okay, this is normal faulting system. Okay, so if I want to describe the stresses in this point, I need to use a tensor to represent stresses in this point. But if I'm talking about each one separately, it is just a vector can do that. Okay, we already explained the picture in the right side. This is showing the hydraulic fracturing, how it increase the contact area between the reservoir and the wellbore, and how it bypass the formation damage. And number three, how it creates a very conductive surface by using propellant, which keeps the fracture open after pumping. And for these three reasons, hydraulic fracturing improves productivity. Mayar, I'm done. So I'm not sure if you have more questions or we can conclude the session.
Thank you. Thank you so much for your effort and time for today. It was really, really so beneficial. Thank you so much all for attending, highlighting that this session is recorded and will be uploaded soon on PioPetro YouTube channel. So make sure to subscribe in our YouTube channel. Thank you all and bye.
Thank you very much and have a wonderful rest of your day or enjoy your night. Thank you.